Hello viewers, today we are going to see about acceleration in simple harmonic motion. The rate of change of velocity is the acceleration of the vibrating particle. So acceleration is given by dv by dt. Okay, but velocity is d by dt of rate of change of distance. So ds by dt. So in our case the displacement is mentioned as y. So dy by dt. So acceleration is equal to d by dt of velocity. We already got the relation for velocity, which is a omega cos omega t. So this is velocity. If you go through the previous video, you can see that velocity is equal to a omega cos omega t, where omega t is equal, we can represent omega t as theta. So this is velocity. Now if you differentiate this one, you will get acceleration. So acceleration is equal to a omega is constant. Differentiation of cos omega t is minus sin omega t. Then after differentiating, you have to differentiate this omega t. So the differentiation is carried out with respect to t. So differentiation of omega t, omega is constant. Differentiation of t is 1. So now this will become minus a omega square sin omega t. This is acceleration. Now if you carefully watch, this acceleration can be written as a is equal to d square y by dt square, which is equal to minus omega square y. So minus omega, so this can be written as minus omega square a sin omega t. This a sin omega t is nothing but y. Already we have seen the displacement in the previous videos. We have seen that the displacement y is given by a sin omega t. So this a sin omega t can be replaced by y. Now this is the equation for acceleration. Now we will draw the diagram. So this is y, y dash, x and x dash. So the particle is starts moving from the point x and it revolves the circle. Now we consider a particular instant of time. Say the particle is at p. The p is the particle, it is at this point. Okay. Now you drop a perpendicular with respect to y dash. Now this angle is theta. The radius of the circle is a. This point is n. The displacement on is referred as y. So if you consider, so since this is theta, this is also theta. Why? Because these two are parallel lines. So if this is theta, this is also theta. Now if you consider this triangle, this is 90 degree. So this is A is the radius. The centripetal acceleration of the particle P acting along PO is V square by A. So the acceleration acting towards the center is called centripetal acceleration, and the value is V square by A. So here this value is V square by A. So this is centripetal acceleration. Now we will consider this triangle and try to resolve the horizontal and vertical components. So this is horizontal component and this is vertical component. So the diagram is redrawn here. So this is theta, this is P, N, this is O, this is Y, and this length PO. The radius is A, and the centripetal acceleration is given by V square by A, and the radius OP, basically OP is the radius and the radius is A. Okay. Now in this this is 90 degree, in this triangle cos theta, and then we have sin theta. If you consider sin theta, opposite side is Y, hypotenuse is V square by A. If you consider cos theta is adjacent side is Pn divided by hypotenuse is V square by A. Okay. Therefore, this Pn, if you consider this equation, Pn is equal to, you move this term to the other side, it will become V square by A cos theta. Okay. Similarly, you move this term V square by A to the other side. So Y is equal to V square by A sin theta. V square by A cos theta along this direction Pn. This is not going to affect, because acceleration is moving towards vertically downwards. So we are interested only in the vertical component, not in the horizontal component. Therefore we can say the component V square by A cos theta along Pn perpendicular to OY. So this line is perpendicular to OY, has no effect along Y dash. That is, this horizontal component, which is V square by A cos theta, does not have any effect because acceleration is vertically downwards. So only the second term is V square by A sin theta has impact. Okay. So therefore we can write So therefore we can write acceleration is equal to only this component. We introduce a minus sign because it is opposite. Okay, so this component is nothing but v square by a sin theta. So v square by a sin theta with a minus sign. So now this can be written as minus a omega square sin omega t, because we know that theta is equal to omega t. So in the place of theta I am substituting omega t. So that's how we are getting this equation, minus a omega square sin omega t. Now once again we can rewrite the equation as, now this equation can be written as minus omega square, this term, a sin omega t is nothing but y. So you must remember y is equal to a sin omega t. Okay. So the negative sign indicates that the acceleration is always opposite to the direction of displacement. That means in this diagram, if the particle moves this way, the displacement keeps on increasing, the acceleration is downwards. Okay. So when it comes at this point, it is upwards. So therefore the displacement and acceleration are quite opposite. That's why minus sign. The negative sign indicates that the acceleration is always opposite to the direction of displacement and it's directed towards the center. Now we will see some special cases. Special case 1. Special case 1. Now, when the particle is at the mean position means here at this point y equal to 0, because there is no displacement. Suppose the particle P is at this origin or x at the point x, then there is no displacement, so y value is 0. So the acceleration in this case, so what will happen to the acceleration? Y value is 0. Therefore, since y value is 0, you substitute in the equation, acceleration is also 0. This is case 1. Next, when the particle is at the extreme position means the particle can be here, the maximum displacement, or which is equal to a. If you consider this side, this is the maximum, negative maximum, it is minus a. If you say this as plus a, this will be minus a. So case 2, we can write when the particle is at the extreme position, that is y is equal to plus or minus a. Case 2. So this point or this point. Here the maximum displacement y is nothing but a. So what will happen to this? Suppose if you take plus a, you will get a, that is here a is acceleration, where here a is the radius of the circle, is equal to minus omega square. So maximum displacement you will get a. Same the same acceleration will become, when you substitute minus a in this equation, y, so minus into minus plus, so you will get omega square a. That means when y is equal to plus or minus a, acceleration is equal to minus or plus omega square a. Now this you should not forget. Here if it is plus or minus, acceleration is minus or plus. That is plus means here it will become minus. If it is minus means here it will get plus. So acceleration is equal to minus or plus omega square a. This is case 2. Now we can write the acceleration. So acceleration, we have this equation. We have one more equation which we have done already. So now we will see the equation of the equation. You bring in this is also equation of the acceleration. Why? Because acceleration is dv by dt. So or you can velocity is ds by dt. So twice if you differentiate the distance, you will get acceleration. So d square y by dt, here displacement is nothing but y. So d square y by dt square, we got minus omega square y. So the differential equation, of simple harmonic motion. From this equation we can write straight away, combining these two, which is d square y by dt square. This minus term will come this side, plus omega square y is equal to 0. Right hand side is equal to 0. So this is the equation of simple harmonic motion in the differential format. Using the above equation, the values of displacement, velocity, acceleration for the simple harmonic motion can be calculated. It will be clear for the above that at the mean position y equal to 0, velocity of the particle is maximum. Mean position at 0 means at this point, velocity of the particle is maximum, but acceleration is 0. At this point, when there is no displacement, velocity is maximum, but acceleration is 0 because y value is 0. That's what we have seen in the case 1, when y equal to 0, displacement we have seen. At extreme position y is equal to plus or minus a, the velocity is 0. In the previous case we have seen velocity at this point is 0. Here also it is 0. Whereas we have acceleration, and the acceleration when y is equal to plus or minus a gives you acceleration of minus or plus omega square a. Acting in the opposite direction. So that's all about acceleration. In the next video we will see about graphical representation of simple harmonic motion, and we will compare displacement, velocity and acceleration in tabulation format, and we will explain in detail. Thanks for watching. Nandri.